Okay, so here we have part two of the polygon interior and exterior angle theorem. Yesterday you should have filled that out. You should have filled out this as well. So this is going to be essentially our third page of our notes. I know that seems like a lot, something we haven't done before, but it shouldn't take too long to get through this. Um, Go ahead and copy that down, press pause in the video. We're going to be working on the exterior angles. Just so you know, exterior angles basically means that when you have like a shape, if you were to extend the sides on the same direction of each one, we're talking about the angles that you create on the outside. So again, you just got to keep staying on the same side of that shape. If we extend the side on one, then you start extending it almost like a fan all the way through, and then catch those angles. We're going to see what theorem we get when we add up those exterior angles. I think the best way to show this, though, is through a video. So go ahead and take a second and watch through this.
Okay, so let's display the exterior clockwise. I'm going to move this slider now to make a nice big arc here. So you can see the exterior angles for a triangle are 120. Now let's find the general rule for all polygons in terms of the exterior. So what we do is if we reduce this radius, you'll see all the points come together and they form a circle. And everyone knows that in a circle, the angles are all 360 degrees. And you can see that there with 120 plus 120 plus 120, which is 360. So that's pretty much it. Just to show you where to put the numbers of sides, 4 for a square, change the orientation, move it in, and you see the four parts of the circle. Um, 4 times 90 equals 360, or if you want to find the other way around, 360 divided by 4 gives you 90. If I did this for 6 sides, you can see it'd be 60 because 360 divided by 6 is 60 degrees. Just open that up to show the polygon itself. So it's a hexagon now. So it's a quite nice and easy way to demonstrate it, really. One thing I should point out is in terms of radius, what does radius mean for a polygon? Because that's really associated with the circle. You can show the circle, which is by giving a colour. So there you have it there. And on any regular polygon, all the vertices lie on the circle. You might be asking, well, exterior angles for regular, what about irregular? Well, one way to do this is move the points or press this random button, which randomizes the polygon itself, or drag points. Now, you can't use the radius here to reduce it because they're all going to be slightly different. They wouldn't come together at the same point, but they still do add up to 360 degrees. So maybe get a class to get the calculators out, add up all the angles and see if that's true. In fact, you can even move on to a concave polygon if it's a more advanced group. And in this case, we'd be adding a negative number, which would compensate for the extra bigger exterior angles, and it would still add up to 360 degrees. Okay, I think that's everything.
So hopefully that made sense. It's pretty cool that they would just collapse on itself like that. Like the angles would squeeze together and make that perfect circle. And since you're making a perfect circle, then we know it's going to add up to 360 degrees. It doesn't matter whether you have a regular polygon or an irregular polygon. If the concave, if the polygon is kind of collapsed on itself, it doesn't matter. It's still going to work out. Okay, so if you look at the notes, it says the sum of the exterior angles of a polygon will always add up to 360 degrees. And we're going to go ahead and write that, why is this true? Because the angles will collapse on itself to make a circle. Okay, so we're just going to go ahead and highlight this. Exterior of angles of a polygon will always add up to 360. And that's because they collapse to make a circle. All right, so now that we know if we were to collapse these, we would get a full circle, then we're going to go ahead and use that theorem to go ahead and get these angles added up to 360. So if I take this angle and add it up with this angle and add it up with this angle, notice that they're all on the same relative side of that You make sure that you don't pick like the angle over here, right? You want to pick this smaller one that's constantly on like that other side of it. All right. When you add those up, we're going to get 360. So I'm going to go ahead and write x plus 150 plus 120 equals 360. That means x plus 270 equals 360. Subtract 270 from each side. I get that x equals 90. And I was able to find that exterior angle. Okay. Pretty straightforward once you have this. You just have to make sure you're staying on the same side of that line. Okay. So we're going to go ahead and run this again. Same thing. It doesn't matter if it's four sides. So I got four angles this time. But again, when it collapses on itself, it's going to make that full circle. So I'm going to add this angle with this angle with this angle with this angle. Again, notice that I'm staying on the same side of those exteriors. Those angles are on the outside. That's also very important. If you get an angle on the inside, it's not going to work with this formula. You're going to have to take that angle and somehow flip it to the outside. That doesn't mean flip it like, oh, it's going to be the same. I'm saying flip it like make sure you'll be able to figure out, if you know this angle, you should be able to figure out that angle because they're going to be supplementary. They're making that straight line. And you'll see that in one of the upcoming problems, okay? But these angles are all on the outside and they're all on the same side, so I can go ahead and just start writing my formula. I get 2x plus 10 plus 3x plus 25 plus 90 plus 100 is going to equal to 360. We're just going to go ahead and combine like terms. I know that looks really complicated, but honestly, it's really not that bad. 5x, and then if I combine the 10 with the 25 with the 90 and the 100, I add all those numbers up together and I get plus 225 is equal to 360. Subtract 225 from each side. I get 5x is equal to 135. And then we divide both sides by 5, and you get that x is equal to 27. I didn't ask it on the last time, but did I answer the question? Yes, they asked me for x, and I sure enough got it. Okay. Hopefully this is not so bad. This is where it starts getting a little bit trickier. It says, what is the exterior angle of a regular octagon? So again, notice that they're talking about exterior. Exterior means we're going to add up to 360. And because it's a regular octagon, I mean, I could draw it. It's just going to take a long time. So that's why I decided not to do it. But if I were to draw a regular octagon, right, you're talking about all of these angles that are exterior like this. Notice that I'm going kind of all in the same direction, right? When I mean the same direction, like I don't want you to all of a sudden start going like this way. Like that would be the wrong way. You got to follow the pattern and go this way. Hey, if it's a regular polygon, that means all the sides are the same. That means all these angles are going to be the same. Okay. Why is that important? Well, that means I got 1, 2, 3, 4, 5, 6, 7, 8 angles that I need to worry about. And it's regular. So all of these angles are going to be the same. Remember, that's going to be 8 angles. And I don't know how much each angle is. I'm going to call it x. But when I add all of these x's, x plus x plus x plus x, 1, 2, 3, 4, 5, 6, 7, 8. I know when I add up all those angles that are going to be exactly the same because they're a regular octagon, they're going to add up to 360. That means those 8 angles put together is going to be 360. That means we're just going to take that 360 and divide it evenly by 8. And if you do that, you get 45. Some of you guys were able to, I'm sure, be like, well, can I just take the 360 divided by 8? Absolutely, right? That's the shortcut. But if you wanted to see the long way, like, hey, why are we taking 360 and divided by 8? It's because you have 8 angles that are all exactly the same. They're going to add up to 360, okay? So shortcut, if it's a regular polygon, just take the degrees and divide it by the number of sides, and that should be good, all right? Okay, now for the last one. The last one, we have something that looks very straightforward. And at first glance, it looks really easy. We're just going to go ahead and add up all the exterior angles like we did before. That means I'm going to add up this one. I'm going to add up this one. And I'm going to add up this one. And I'm going to add up this one. And this is where you have to be careful. The outside angle is this one. This is what I was talking about earlier. I don't have that outside angle. I have the inside angle. So then how do I flip this over here? Well, those are both not going to be 130. That doesn't work because remember, this is a straight line. And I know that straight lines add up to 180. So if this is 130, then something's missing over here in order for me to get that 180 total. That number would have to be 50, right? Because 50 plus 130 gives me the 180 total, okay? So that's what I'm saying. Make sure that you're adding the outside angles. I was able to figure out that this angle has to be 50. Now that I have all the outside angles, I know I'm going to add them up and they're going to add up to 360. So I get to go ahead and write 73 plus 50 plus 4x plus 3x plus 2x plus 30. That's all 5 angles, I believe. They're going to add up and they're going to add up to 360. I'm going to go ahead and combine like terms. That's going to be 9x's plus, and when I add up this one, and this one, I'm going to get 153 is equal to 360. Subtract 153 on each side. I get 9x is equal to 207. Divide both sides by 9, and I get x is equal to 23. And I believe they told me to solve it for x. They did. That is my answer. And that takes care of the notes for exterior angles, okay? As always, if you have any questions, please feel free to ask.